So in this video we introduced a very important concept of subspaces of vector spaces. Let us say we have a vector space here, V, over a given field F. Okay, let me call it, sorry, this is for abstract algebra. Let me call it K here. Okay, I'm going to call the field of scalars K. And let us say we have a subspace here W. Okay, so if W is a subset of a vector space over a field K, this W here will be called a subspace. A subspace of vector space V if W itself is a vector space over K, of course with respect to the operations of vector addition and multiplication, the normal stuff. Okay? Okay. So W is a subspace of V if and only if W is non-empty. We have other ways to say this, but I'm going to say this quickly here in this way. So W is non-empty. 2. If for any vector U and V in W, W is closed under addition, so U plus V is in W. And 3, if V is in W, that means that KV is also in W, in the subspace, okay, for all K in the field of scalars. So if these three things happen, we say we have a subspace of the vector space V. Okay, we say that W is a subspace of the vector space V. So now that I introduced the concept of subspaces, we have a very important corollary. So W will be a subspace if and only if the vector 0 is in the subspace, or, and this is the same, W is non-empty. Second, for all V and W vectors in the subspace, that means that A, this will be scalars, A and B will be scalars in the scalar field, A times V plus B times W. I should, wait a sec, if A times V plus B times W are also in the subspace. Okay, so that's the corollary. W is a subspace if and only if the vector 0 is in the subspace or 0 is non-empty, or for any vector V and W in the subspace, it implies that A times V plus B times W are also in the subspace. Well, an important concept here is if we have a vector space like this one, the smallest possible subspace will be vector 0 here. Okay, so 0 is this set consisting of the 0 vector alone is a subspace of V. In fact, is the smallest subspace of V, because it is contained in every other subspace of V. Okay, so this one will be the smallest subspace of the vector space. And of course the biggest subspace of the vector space is the V itself. Okay, so V is also a subspace, a trivial subspace of vector space V. If you check, everything will be in. Okay, so V is not empty. If you add two vectors, you'll be in the vector space. If you pick a vector and multiply by a scalar, it will be in the vector space. So V will be a subspace of V. Okay, so here you can replace and say V is a subspace of V. In fact, that will be the biggest subspace of V, and the set with vector 0 alone will be the smallest subspace of V.